for AI Fabric products specifically, and we have seen till now all the out of the box models of AI Fabric, predefined models of AI Fabric, and we have also created live workflows within these sessions. So this is the last session of the entire series, and this session will be very interesting, is because we are going to look at a very great and awesome use case which we will build using TPOT AutoML classification model. Now, before I get started with today's session, let me show you and let me quickly recap what all we have covered. So let me quickly navigate to platform.uipath.com, where we can see all the AI Fabric components. So I'm navigating to admin, I'm navigating to my AI Fabric component. And as you can see on screen, I already have predefined two models. One is diabetes prediction and another one is profit prediction. Okay, so we will talk about this later. But first of all, we will see what all things we need to consider and what all things we have already covered within this particular series. So let me quickly navigate to ML packages. I will navigate to out of the box packages here. So in this, we have completed, we have seen how image analysis works, and we have seen an example of object detection in our first session. In the second session, we have covered language analysis, where we have used English text classification model, and we have identified feedbacks from the restaurant sentiment analysis. In the third session, we utilized sentiment analysis model, and we created wonderful bot for sentiment analysis and compared it with Python. In the fourth session, we used language comprehension to deploy a model of question and answering, and we created a bot which can interact and answer your questions based on the paragraphs as an input. And in the previous session, we saw how language translation can help you increase your scope of international communication. Now in today's session, we are going to talk about one of the most important machine learning models, and very complex but very easy at the same time to use, which is nothing but tabular data models. So in the tabular data model, we have four machine learning models, which are out of the box packages. Out of these four packages, so these packages are called TPOT AutoML classification, TPOT AutoML regression, similarly TPOT XG boost classification and XG boost regression. Okay, so we will quickly see and quickly look at the description of each and every one of them, and then we will look at how can we leverage these models to use in our workflow. Okay, so the very first model which we are going to look at is TPOT AutoML classification. Now, first of all, what is this TPOT? So TPOT is nothing but a Python automated machine learning. Okay, so you can call this TPOT as a Python automated machine learning tool, which automatically optimizes machine learning pipeline using generic programming. Okay, now what happens here? You can see if you train your ML package before deploying it, okay, it will not return anything. If you do not train it, it will not return you anything. But how TPOT works? TPOT can work on an entire tabular data where you have multiple columns as your feature and a single column as your target data. Okay, now I will explain that in more brief when we jump on the use case, but as of now, just try to understand the difference here between the classification and the regression and what is TPOT. So TPOT will automate most of tedious part of the machine learning by intelligently exploring thousands of possible pipelines to find the best one for your data. So TPOT automatically does that in background. Isn't that great? So once TPOT is finished searching, okay, it provides you with a Python code for best pipeline it found, so you can tinker with pipeline from there. So you do not have to download that Python code and edit it again to modify with your data. You do not have to do that. TPOT can give you the same Python code in a format of already deployed model in the pipeline when you complete the training pipeline. So all you need to do is then you need to run the evaluation pipeline and you're good to use it. Now TPOT is built on top of scikit-learn, so all the code it generates should look very similar and familiar to scikit-learn users. The model is completely based on publication entitled of the scaling tree based automated machine learning in bionomical data, big data with a feature set collector. Okay, Now, how does this exactly model works? So what is the input format? So input format is a tabular data. Now let me show you a very quick example of input format. So let's say I have this data here, okay? So in this data set, you can see, so I have five columns here, correct? Out of these 5 columns, the first column explains that what is the R&D amount spent. So these are all the amounts in dollars, okay? So first column explains that R&D amount spent on a overall year to research on R&D, correct? Then what is the amount which is spent on administration department? What is the amount spent on marketing spend? Now state. So this entire data is divided in only 3 states, and that's why I have given codes to the states, is because we need numerical data as a feature. Now let me first of all explain you what is feature and what is target. So the value which you want to predict from machine learning is your target column, which is definitely here profit. Okay, I want to predict the profit. And the values which you do not want to predict, but which works as a training material for training your particular machine learning model, these are called as features. Now, as you can see here, there are 4 features and there is a single target column. If you might have looked at English text classification, in that model, we used only 2 columns. The first column was the feature value and the second column was the target column. Now in TPOT, this cannot be only limited to 5, but your features can be of n number of features. But your profit or your target, but your target element has to be only 1. So you can predict your target column. Now that is the first requirement, okay? Now what is the second requirement to use the TPOT model? The second requirement to use a TPOT model is that all the feature columns have to be in a numerical data or in a digits format. It should not be characters. So earlier these states were characters. So let me show you how this data looked earlier. So this is the original data. Let me open the data quickly for you. So this is the original data, okay? Now in this data, as you can see here, the states were characters in character format, or you can call this as string where there are no integer values, correct? Now this comes in a part of feature, and as it comes in feature, we have to convert this data in a numerical format or in an integer format in order to use and pass this model as in training. So this is the specific requirement of this TPOT model. So you have to convert this into integer. Now, how do you convert it? So if I simply put up a filter here, and if I just check how many possibilities of states are there. So there are only 3 possibilities. So I can replace California with 1, I can replace Florida with 2, and replace New York with 3. So I can give a code to the specific states. And if I give a code, it will automatically be numerical, and then my requirement is satisfied. So this way I can simply use this model, correct? And the last rule is the target column. So your target column can be a text data. Now this is a great advantage because UiPath's TPOT AutoML regression can automatically convert your target column, even if it is in a text format, in a string format, it can convert that into integer format automatically. You do not have to worry about that. But if your target column is already in integers or already in numerical format, then you do not have to worry about transforming the data, or you do not have to worry about anything. You can simply get the prediction in a numerical format. But if your data is in a string or a characters format, that data, the target column will automatically be converted into integer. But when you receive the output, it will again be converted back to characters so that you get your correct answer. So this is how easy it is, and this is how simple this model is to use. Now, whatever I just said, you can get all that information on UiPath documents and nothing else. So I'm just simply going to say TPOT, and I can see here. So I'm going to use open first of all classification, and then I'm going to use for the second thing is AutoML regression. So you can see here TPOT AutoML classification. So in the classification model, you can see here, it is very simple. So the input type is JSON, okay? The input description is, it needs JSON in this specific format. And the output description, now you can see here, output, there are two types of outputs. If your target column contains characters, so you can get the response from output column as labeled yes. So you will get labels in a string format as a written. But if your target column is already only numbers, you will simply get this output, which will contain predictions and confidences with the integer values. So you can get the response in these two formats. Now, what are all the pipelines you need? So you need, you can enable all the pipelines. You can run full pipeline, training pipeline, evaluation pipeline on these both models. Okay. Training pipeline will help you to train the model. Evaluation pipeline will help you to evaluate and to verify what is the accuracy of that particular model. So let us try to go ahead and let's try to deploy one of the model. Okay. So what I will do is I will quickly jump here on AI Fabric. I will quickly create a project and I will say profit prediction, okay? Or I can simply say profit TPOT, okay? Using auto ML regression. Now, I have to first of all upload a data set here, correct? So as we know already, we have been looking into it from the first session. So what is the standard ratio of keeping data? So training data should be 80% and test data should be 20%. So if you have 100 rows in one Excel file, 80 rows should be in training data and 20 rows should be in test data. I'm just talking about hypothetical scenario, 80-20%, okay? But you might end up with having a lot of data, huge data. So split it in a way that you pass 80% of the data to the train and 20% of the data to the test model. Okay. So where are these files? So these files are in document AI Fabric 50 startup. So I have this data here, train and test set. You can see it. What I'm going to do is I'm going to quickly upload. I'm going to quickly create a folder. So I'm going to create new folder here, which is going to be named as train data. I'm going to create it and upload a file here. So upload a file will take me here to browse the files. So I will click here. I will simply navigate to the files, which is in AI Fabric, 50 startups, and I will simply select this train.csv. Now, one more thing, your input data has to be always in a format of CSV. Okay, so that is nothing tough. That is simply just like Excel file. You just have to convert your all the data into CSV format. Select the CSV format and upload it. Now, as soon as you upload, it will be reflecting here. The size you can see here 2.7 KB, 2.07 KB. Type is file created on this time. Now I will create one more folder for test data. So I will say here simply test data, and I will create this folder. Upload a file, click here, and upload the test.csv and click on upload. So this will be uploaded right here. You can see here this file size is very small, 561 bytes, and that is the main reason why we prefer to use CSV, is because CSV can store huge amount of data within very small amount of file size. That is always referred to any machine learning program as an input data set. Now we will go to ML packages. We will go to out of the box packages, navigate to the tabular data, and quickly look at the TPOT auto ML regression. Now, why am I using regression and why I'm not using classification? I will explain you the difference very quickly. So what is the difference in the classification models and the regression models? Can anyone tell me in chat what is the main difference in classification and regression? Anyone? If you have a small idea about it.
You can answer on chat.
Guys, you can answer on chat. Okay, no problem. So I did not receive any answer. So let me explain you very quickly. So what is the main difference between classification and regression? So for example, my target column. So this is my target column, correct? Now, as you can see here, target column, each and every single row has a different value, correct? Now there is no specific class which is being followed here. Now what do I mean by class? If my target column would have been state instead of profit, correct? If my target column would have been state, let's say my target column is a state, I want to predict for which state, and this all columns would be my features. So there are only three options to predict, either 1, 2 or 3 based on the input data. So if there are specific definite number of classes in which your data will be classified and you simply need to predict the category of that classification, that time you will go ahead and you will simply use AutoML classification model. I hope I'm clear. So whenever you have a column to predict which has specific number or which has a set of predictions, which is 1, 2 or 3, either one of these three will be the answer, you have to predict the class. In that case, you will simply use AutoML classification model. But when you have to predict a regression value where the value completely depends on the experience of all these 4 features, and value is not at all a class or it's not a set, while value differs for each and every row, in that case, you will go ahead and you will use TPOT AutoML regression model. Okay, I hope I'm clear with this point. So for this particular use case where we are predicting profit for these organizations, we are going to use TPOT AutoML regression. So I will select the regression model. I will select the package version, which is 1.0, click on submit. I'm going to rename it as TPOT profit prediction, let's say, and I'm going to simply say submit. Now I told you previously also, so we are going very step by step. So the first thing is that we went to dashboard, we uploaded the data set, now we created ML package, and now we will jump on pipeline. The very first pipeline that we have to create is a train pipeline. So I will click on create new, I will click on pipeline, and you have options of 3 pipelines, correct? So train is the pipeline which is used to train your data set and create a model out of it. Evaluation is the pipeline which is used to evaluate the response of the train and evaluate and check whether how accurate the training has been performed. That is why evaluation dataset always has to be a different dataset than training dataset. So you cannot just take out the 20% piece out of the train data and just put it into evaluation. You have to use a different dataset altogether. Whatever the rows will be in the evaluation dataset should not be matching with the trained dataset. Then only you will get to know the exact accuracy of your machine learning model. So I'm going to use train run here. The package I'm going to select is TPOT profit prediction, which we just created in the ML packages. The version, the major version I'm going to select is 1. The minor version I'm going to select is 0. The input dataset, now you can see input dataset automatically here as we have uploaded in the datasets. So I'm going to select train data. And now, do I need any parameter? Definitely. Now let's navigate to AutoML regression and check. So I navigated to the documentation of AutoML regression, and I am checking here in the environment variables. What are all the environments variables that I need? So the first thing I need is a train time. The second thing is target column, scoring, and keep training. So train time by default is 2. So I'm not going to modify this. Target column is by default target, but our target column is different. So I'm going to add this parameter. Let us copy target column here and create an environment variable here called as target column. What is the name of the target column for our data set? Can anyone tell me what is the name of the target column here? You can post your answer in chat. What is the name of the target column? Profit. Perfect. So what I'm going to do is I'm going to simply say profit here with P capital. Make sure that you're following all the cases, uppercase, lowercase perfectly. Profit, I clicked OK, and I'm clicking on create. Because I do not have GPU, I will just keep it offline. I will say run now, create, and I started this pipeline. Okay. Now it will take very small amount of time to run this particular pipeline and then create a model out of it. Okay. So before it generates all that, let me show you, because I already have created 2 projects. Okay. which is profit prediction and diabetes prediction. So let's navigate to profit prediction and let's look at how it creates a model out of it. So this is already trained data. I will navigate to pipeline. As you can see here, it has shown here trained data, which is successful, which took 409 seconds. Okay, and I can actually click here and I can see details. Now check this. So I clicked on here, I saw details. I navigated inside and I can see that it has created a profile, a profit prediction .zip file, which is of 155 KB, which is the entire project trained. Now, if you remember correctly, we talked about it. So what exactly AutoML classification does, that TPUT is the most tedious part of machine learning by intelligently exploring thousands of possible pipelines to find the best way for your data, correct? Now it will create a best way to train the data and it will train the model. That is, right, this one, profit prediction.zip. So I'm going to download it. As it is very small data, I'm going to download it very quickly. So let's say we download it in Fabric startup here, predict profit. I want to replace already existing flow, and this is downloaded now. Okay, as you can see here. Also, we have results.json, so I don't want to download that as of now, and I can see the rest of the data. Now let us navigate in the zip file and let's see what is there in the zip file specifically. Okay, so I'm going to unzip it right here, and I'm going to extract it correct here in the profit prediction folder. Now it is okay, it is available now. Now you can see UiPath has created model.sav. Now this .sav is nothing but your machine learning model, which is trained model. Based on this SAV file, all the predictions are made. Remember, SAV is generated by pickle method, and this SAV model is nothing but your machine learning model, which answers and which predicts all the things that you provide as an input. It predicts all. It helps you predict all the predictions. Main.py file is the main Python file. Let me open it with the Sublime text for you so you can see. So this is automatically generated, as you can see here. Okay, which also includes automatically JSON, Panda, JobLib, scikit-learn, collections, and NumPy. Okay, because it is more over natural language also is included. That's why it will take NumPy also. And scikit-learn is already there, as we saw in the description. It will also satisfy all the requirements automatically. You do not have to do that. It will generate the train.py file also if you want to retrain the particular model. You can see configuration py and you can see all the models. So this is the model which is created, which is also present here. Perfect. So with this model, as you know, you have already got the model. So let's navigate back to workflow here, and this is how you get it. Now let me navigate back to the pipeline. So once you complete pipeline of training, you have to run a pipeline of evaluation, obviously. So as you can see here, the score of evaluation is 85.78, which is almost 86%. So 86% is way too nice score for such a small data, because I have trained a data set which is very small. So you can see here, the data set I have trained is only 50 rows of training data, and hardly 10 rows of test data, is because we want to keep the ratio of 80% and 20%. Okay, let's navigate here and click on details, and let's check what do we get when we successfully complete the evaluation pipeline. And the evaluation pipeline, you can receive the JSON format file, that is it, and you can see all the logs which are there to run this particular model. Okay, so here we complete the pipeline. Let's navigate and check what is the status of our pipeline, which we just deployed. So we deployed profit prediction TPOT. Let's check the pipeline. So pipeline is still running. You can see here, training is being happening right now, and the status is still running. So it will run for a couple of seconds, and then it will say completed, or it will show the status as successful. Okay. Now, once you deploy this, you can go ahead and you can predict all the, you can enter and you can give input R&D spend, administration, marketing spend, and state code, and you can predict the profit amount just by these values. But now here's a trick. Okay, what happens in classification and what happens in regression? So in regression, whenever you enter the data in input format and you give the data, the output or the profit predicted is not going to be exactly accurate or exactly matching with the number. So here profit is 19. So you can see 1,92,261. Okay. But when you talk in that way, profit is not always going to be exactly same, correct? It is going to be a little bit different. So it could be something around 1,82,000, maybe 345, something like that, 0.21 or something like that. Now it could be nearby or close to this. So with the close threshold, how much the number is closer to this profit that is there, we can compare whether our accuracy is correct or not. But exactly it is opposite in case of a classification model. So in case of a classification model, you have specific classes defined: class 1, class 2, class 3. I'm just giving an example of this. So your answer is not going to be different than these three. Either it could be 1, it could be 2 or 3, but the accuracy of the prediction is going to be 100% accurate, that either it is 1, it is 2, or it is 3. And that is why classification models are used only to classify the tags or only to classify the data under specific categories. Okay. And regression model is used to predict the futuristic definition of the current data or the historical data. How is it going to draft it in the future and based on the experience of the previous data. So this is how this both model works. We have right now deployed one model for the running, which is for train set. I'm going to refresh it. It's still running. So we can come back to this later. Now, let's look at how this model is going to take an input. So as you can see here, we already saw the input format for this model is going to be completely a JSON format, correct? So once you see it is in a JSON format, let's try to see how can we get the data for this particular model. So as you can see here, I have already deployed one of the model. The model is profit prediction. Let us check whether it is visible in our orchestrator or not. So I will navigate to actions, navigate back to orchestrator. And I'm navigating to the ML skill. As you can see here in the ML skill, I have already deployed two models. One is diabetes prediction, another one is profit prediction. Okay, the profit prediction model, there are no predictions as of now made with this model, and it is available. So let's try to use this model in our workflow. So what are we going to do is we are simply, so this is the UiPath Studio, and what I have done is I have created a simple flowchart here. Okay. Now within this flowchart, I am simply going to drag in an ML skill to show you how this exactly works. Okay, and later on we can look at the deep insights. This is the ML skill. Let me refresh it, and two models are currently available as you saw on screen. So let's open this, and you can see here there are these two models. In order to get the data from orchestrator integrated with your studio, you have to make sure that you are connected with your orchestrator. I am connected to the default folder. You can connect to any folder that you want. You can use modern folder, you can use default folder, but you have to be connected to the same orchestrator where you have deployed the ML skill, okay, or the same tenant, because when you deploy ML skill, it is deployed on a tenant rather than entire orchestrator, okay, specific tenant. Now I'm going to open this and I'm going to select profit prediction. In the profit prediction, I'm going to click on test skill. Now, as you can see here, features used by a model to make predictions. For example, let's say feature 1 is 12, feature 2 is this, and feature n is this. And the answer is going to be predictions in a numerical format. So let's try to give the similar type of input here. So for that, I have created a JSON file. Let me copy this entire JSON and let me come here in the browser to show you. So this is the JSON file which I have already copied. Let me expand it for you. So let me copy this, put it in Notepad, and show you. So yes, so this is how this JSON looks. So this TPOT model, or it is not only for regression, but regression and classification, both the TPOT models accept input in this format. Now, what is the format? So here, this value, or you can call this is the JSON file, correct? So the key value is nothing but the name of the column. So you can see here in the train data, the name of the column is R&D spent. So the key value has to be that in double quotation, and the pair value has to be in a square bracket because you are using a numerical data. So square bracket indicates this is a indexed JSON. So by means of indexed JSON, I mean that the JSON has numerical data, or you can say JSON has double data. Okay, the data type is double or numerical, let's say integer. Okay, then you have to give the second column name. You can see here administration, and it is enclosed in double quotation also. And the value of the second column is given here in the square bracket, similarly like this. And in this way, when you define your data, now let us try to catch any data out of this train model. So let's say if I bring the data from row number 40, okay, let's hold this row. So let's say my R&D spent is this much, okay. My administration is this much. My marketing spent is 1,80,265. And the state is California. I know the code one is for California, so it's going to remain same. Now what's going to happen? If I copy this entire JSON file, let us copy it to first of all a JSON parser so you can see the data. I'm navigating to a website called as JSON Parser Online. I'm going to paste it here. You can see here this data looks like this data looks like this. R&D spent the value, administration the value, marketing spent the value, state the value. Correct? Now I'm going to copy this data, and I'm simply going to UiPath and enter here in the input dialog, in the input box, and simply click on test skill. I got the response, which is 71509 something blah blah blah. So I'm just going to copy this data, come here in the train set, and I'm going to paste it here. Now if you look at it very closely, okay, so this is the actual value of the profit, you can see, and this is the predicted value of the profit. So the actual value is 81,229 and the predicted value is 71,509. So there is a difference of 10,000, almost 10,000. However, the data is pretty close to the range of the range of the plus or minus ratio that is expected from this data. At least this data is not into some lakhs, because this data, as you can see here, is 1,56,000. It is not like that. So this data is merely close to this data. Now I have already trained only 50 rows, and that is why the accuracy could be a little bit here and there, but you can increase the accuracy by increasing the data. That is a directly proportional. So the more data that you add to training and testing, the more accurate your model gets. It is always directly proportional to the model accuracy. But as you can see here, the data accuracy is pretty much good. Now let's try to get a data set which is more into more than thousands, more than 100,000. So let's look at this data. Okay, so let's try to copy this, and let's try to set this data here in the notepad. So what I'm going to do is I'm going to pass the R&D spent value. So R&D spent is this much. This is the test data. And administration is this much. Okay. The marketing spend is how much? Let's look at marketing spend. So marketing spend is this much. And the state is this time third, which is probably New York. So I'm going to say 3. Okay. And I'm going to copy this JSON file, this newly created JSON file, and I'm going to copy and paste it here in the JSON parser. Let's look at this data. Okay, so this is how it looks. And let's try to pass this data as an input to our UiPath Studio. So we will pass, instead of this select input, I will pass the new data and say test the skill. Now based on the prediction, now let's copy the prediction from here. And let's navigate back to the Excel. Now for this data, we got the prediction of, now look at the closure of the prediction. So here the prediction is 141,587, and here the prediction is 128,222. which is again close because there is only a difference of maybe 10,000 or 11,000 in the price, and that is why this regression model is so I as I mentioned earlier, classification model is always 100% accurate, but regression model's accuracy always lies within the threshold value. So here, if we keep a threshold of 10,000, the value is either going to be greater 10,000 or less 10,000, but it's always going to revolve around this original value, which is to be predicted. So we can at least predict a rough figure of the futuristic data based on the input data here. So this is how this model works, and this is how easy it is to use this specific model, which is TPOT AutoML regression. Okay, now let me show you what I have built for TPOT AutoML classification. And also we will look at whether our data is completed or not. So let's navigate back to our admin. We'll navigate to our AI Fabric. So as you can see here, the pipeline has successfully completed within 493 seconds. Okay, let's refresh it. Now we have to create a new pipeline. The second pipeline is going to be evaluation run. So I'm going to select evaluation run. Okay, I'm going to select the pipeline, select the package which is TPOT profit prediction. Select the measure version as 1. Now what is going to change in the evaluation run? So in the evaluation run, only the thing changes is the package minor version, because you now already have a trained data. So you are going to select 1. So your new model which will be deployed is going to be 1.1. And the evaluation data set, I will select test data, is because we are utilizing test data for evaluation. And similarly, we have to enter the parameters. So what is the parameter for this? The parameter is nothing but target column. So we will add this target column here, and we'll pass it here the value as profit, because this is the name of our column, right, in the target column. And then I'm going to simply say create. Now, as soon as I created this evaluation pipeline, it is again going to take a couple of seconds, maybe 200 seconds, 100 seconds, which is like a couple of minutes. And after 1 or 2 minutes, you will see how accurately this model is being trained. And you can also download the model here. Now, once the pipeline is completed, once the training pipeline is completed, once the evaluation pipeline is completed, and once you reach out to the final pipeline, which is full pipeline, that is only used when you want to retrain the data. Otherwise, if you are satisfied with the data set training and satisfied with the predictions, you can still be done with the trained pipeline and evaluation pipeline. Wherein, if you want to upgrade the data, you can anytime train the model again on new data set and create a new model for that. So you can do that in AI Fabric. Okay. Now let me check quickly if any questions are there. Okay, perfect. There are no questions yet. So I think you all are following me as there are no questions. So this is great. Now let's navigate and let's look at what we can create with AutoML classification model. So I will simply navigate to AutoML classification here. And this bot is actually a very big bot. I cannot show you the entire bot build right now because it is way too long for me to show you that. The time taken will be more than 2 hours. But I will show you, I'll try to give you a quick insight of it. So AutoML classification is nothing but a bot where you need classification kind of a data. The data which is very fit for classification use cases. Now I had a data which is of a Kaggle's data where I had diabetes data set. Now let us look at the data set here. So let me close this one. Let me close this notepad also very quickly. Let me close the CSV file very quickly. Now let us navigate to the data set, this one. Now what I had in this data, let me open it very quickly here. So as you can see on screen, not this one. Yes, train data. So as you can see on screen, this data contains the columns such as glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and outcome. Now this is a data set in which I have multiple values for glucose, different values for blood pressure, skin thickness, and every column out of these 7 feature columns are different than each other, correct? So there are no classes here. But luckily, the prediction column from where you want to predict whether a person has diabetes or not is nothing but classified in only two formats, which is two classes, which is 1 and 0. 1 stands for diabetes prediction corrected, that means diabetes predicted. 0 stands for diabetes is not predicted. So if you want to see the data, let me click here and let me click on the filter here very quickly. So if you can see here, you have two classes, 0 and 1. Okay, so 0 stands for the class which is representing there is no prediction of the diabetes, and 1 stands for that there is definitely diabetes to this particular patient. And this is the data set, which is almost, if you scroll here, so the data set is almost close to 615 people, which is a very big data, right? Now, this data, when I train it on the AI Fabric component, tell me which type of model I should use. Should I use classification model or I should use regression model? You can answer this question in the chat section. Which model I should use in order to train the diabetes prediction data? Pooja says classification. Perfect. Now, why classification is because we have only two classes to predict. Either diabetes is yes or there is no diabetes. Now, you can simply upload the similar data set with the train and test CSV to the AI Fabric. Let me show you very quickly how it works. So I will navigate to the pipeline and navigate to AI Fabric, diabetes prediction, and yes. So here you can see I have already created a workflow, a model for diabetes prediction, which is either yes or no. So there is test data and there is train data, correct, which is uploaded right here. There's a similar data which is there in my folders. And then I created a ML package, which is deployed. Then I created two pipelines. One is a training pipeline, another one is evaluation pipeline. So training pipeline is successful. It is showing completed in 314 seconds. For a data set of 600 rows, 314 seconds to train the model is pretty fast. Believe me, because I train a lot of machine learning models on the daily basis in Python, and it takes a huge amount of time to train the model, and to deploy the model in a pickle format. It takes more than 3 to 4 hours to deploy that if you do not have GPU. Okay, but here in the cloud, even if I did not selected GPU option, it processed my 614 rows of data and created a prediction model within 314 seconds. Which is great. Now it also completed evaluation in 53 seconds and gave me accuracy of 77.92, which is more than expected, 78% of a score. So if it is above 78%, that means your model is actually great. Now I got the model with the 78% of accuracy. Let me click on ML skill. Then I deployed a ML skill by selecting the version as 1.1. Remember, whenever you select the evaluation pipeline, you have to choose the previous version, which is 1, as a minor version. That is only when you can create a 1.1 version ML skill, which is created right here in the ML skill, and then you deploy it. That's it. So this is how I uploaded and I created this diabetes prediction model. Okay. Now, when I created this particular model, also along with that, what I used is I used this simple workflow. Now look at the workflow. What I'm doing here is I'm taking values from the arguments. I have given some of the default values to the argument as of now set here. Okay. And I'm passing two values outside. One is prediction and another is confidence. Now the values which I'm taking as input from the argument, I'm storing that value in an Excel file in a specific way. Let me show you the Excel file. So this is the Excel file. In this Excel file, I'm storing these values like this. Okay. And then these values will be converted. This entire table will be converted into a JSON format, which looks similar to this one. Okay. Now to convert this data table format into JSON format of indexed JSON, what function I used is, let me show you. So the function I used is very simple. The function is nothing but, so I created a patient data, correct, which is read from Excel. As enumerable, it is definitely a dictionary value because there are two columns. So dictionary of string and array of integer. I converted the first column, which is test name, into string. And I converted the second column, which is results, into integer by checking it into as a cint, which is a function of row. Okay. And when I converted that, I added all the data into a dictionary variable of string and integer. And simply by doing that, I passed the data by converting it into a JSON file in the prediction model as an input. And when I receive the output is going to be the prediction and the confidence in case of classification. In case of regression, you must have noticed there is no confidence, is because we are not predicting any class or a category. So we cannot actually define the confidence of the machine learning extraction for regression model. Regression model simply works like that. You do not get any accuracy confidence level. So you get here, and once you get the desired output, now if the prediction is 1, that means definitely there is a predicted diabetic. So I assigned here out prediction as a diabetic patient, and for non-diabetic patient, I assigned non-diabetic, and then printed the responses in this format. And I integrated this entire workflow with UiPath apps, and how it works. Let me show you. It is very, very great. So let me navigate very quickly to UiPath App Studio. So in UiPath apps, you can see here diabetes prediction. So I will simply click on run. In this model, so you get to enter all the values that you need to that you need as an input to predict the diabetes. So let's say values. So I will navigate very quickly to this data set. Okay, and let's try to hit with the 10th row. Let's try to hit with this data. Okay, so we can take any random. Let's try to get the 15th row. So I will copy this data, which is glucose. So I will enter the glucose value here in the UiPath app. Then I will copy the blood pressure value. I will copy the skin thickness value. I will copy the insulin value. I will copy the BMI value. I will copy the diabetes pedigree function, and age is 59. And as soon as I click on predict, let's look at the robot. My robot will start running automatically. As you can see on the bottom taskbar, bot has already started. It is running, and it will automatically predict whether this patient has diabetes or not based on the input data. Bot has stopped, and now the data will be displayed below this predict button. You can see here diabetes prediction and prediction accuracy. So the person is diabetic with the accuracy of 78.20, which is more than 75%. So we can say that this person is diabetic. And let's check the response. So yes, the outcome is also 1. That means this person is a diabetic person with the accuracy of 78.20%. Now let's take any person with the non-diabetic record. So let's take this person, which has 0 value. So I will pass the similar data. Let me refresh this UiPath app. So I entered value here. In the 88, I gave value here. 60, I gave value here. 110, I gave the insulin value. 46.8, I gave the BMI index value. I gave the diabetes pedigree function, and age is 31. And now let's try to predict whether this person is accurately predicted as a non-diabetic person, and with how much percent of accuracy. So bot is already started running, and bot is running right now. And as you can see on screen, once the bot completes running, it will show the prediction as non-diabetic with the prediction score of 57.05, which is pretty good, more than 50%. So we are sure that it is non-diabetic because the answer we already know that it is a non-diabetic person. So this is how this model can also be integrated with UiPath apps, which is a very wonderful feature. I have recently uploaded this video on my YouTube channel. You can go ahead and you can watch the entire video if you want to create the bot. But this is how this entire prediction model works. Now we just saw two examples of TPOT models. One is classification model, another one is the regression model. So I hope you must know the exact difference between these both models. In the meantime, we will navigate back to our ML skill and we will check. Let me navigate back to our AI fabric. So I'm navigating back to the AI fabric right now here. And let us check what happened with our pipeline. So I'll click here, I will navigate to the pipeline. The evaluation that we ran is successfully completed within 53 seconds with the accuracy of 85.78%. Now we can create an ML skill for this. So how do we create an ML skill? Click on create new. Just type here profit prediction with TPOT model. Choose the package which you wrote in ML packages. Choose the measure version as 1. Now remember, in order to use the latest version, choose the minor version as 1 also. And then create this particular ML skill, which will be available in a couple of seconds within your AI fabric. And then you can try to go ahead and utilize this AI fabric package within your workflow, just like this, which I have used. So now you know how to create a ML classification model and ML regression model. So I hope you're clear with the thoughts. And this is the most interesting model for me, because I personally love TPOT models a lot, because there are many use cases which we can do within very few seconds without actually having to explicitly sit and code for in Python. Now also it saves a huge amount of time, not only by giving you the ready-made code, but by also saving your time to try and to go ahead and try different models. So what you will do, if you get a data, you will, as a data analyst or as a data scientist, as a machine learning developer, ideally people will go ahead and will try to upload the data set and try to use that data set for multiple machine learning languages, and then go ahead and keep on checking whether uploading this data on the multiple machine learning languages, which model gives more accuracy. But here TPOT model does that for you. You do not have to do anything. TPOT model automatically runs in background and predicts which model is best suited for you along with the best accuracy, and gives you within a couple of seconds only. So this is how great this model is and how useful this model is. I use these two models, only these two models, as a part of my machine learning piece in the recent HyperHack hackathon which happened. And believe me, I won that hackathon with the first rank, and both the models which I used were TPOT, AutoML classification, and AutoML regression. This is how great these models are, which helped me to get all the training time and period very short. So I was able to train my entire machine learning program or entire data set within very couple of few days, and I was able to get more accuracy, and I was able to complete the bot. So that's why these models are very helpful. And that's about it. So thank you so much for visiting to this, for being with me till this entire session. Now we are open for questions.
Guys, I'm making some of you as a presenter so that you can speak as well.
Okay, so
you may try to speak if you want. You can try speaking.
One second. Hello.
Yeah, we can hear you now.
Yeah.
Yes, Piyush.
Sir, I had two questions. Like basically, I was trying the summarize model to text summarization, but I faced that it was taking too much time. So is that because of lack of GPU or something else? Like I was trying to summarize around 13,000 characters were there.
So which model did you use for that? Text summarization.
Yeah.
Okay, so let me quickly check the model here. So this model is from language comprehension, correct?
Yeah.
This one, correct?
Yes.
So this model as of now takes input only less than 300 characters, Piyush.
No, it was like for 300 characters, it was just returning the same string. And if I give more than 300 characters, then it was giving me an answer, but the time consumption was too much. Like I tried with 600 characters, 900 characters.
Correct. So it could be because of absence of GPU. Now, why? Let me tell you very quickly. So what happened, Piyush, when let's say I'm using Python, okay? Now if I try to run something, machine learning models work directly on kernel level, okay? So when they work directly on the kernel level, they eat up a huge amount of space or speed of your CPU. Now, if your CPU is at least capable of handling, if your CPU is more than 20 GB of office laptop, it can handle the it can handle the machine learning prediction. But if your CPU is not that supportive, so it will take very less amount, it will take more amount of time for you to get the data predicted, correct?
Yeah.
Similarly, here is also the same case. As we do not have GPU, the prediction time will be more, right? But if you include GPU, as soon as you include GPU, it will be faster. So the example of that could be if you try to use Google Tensor,
Google
TensorFlow, TPU, Google collaboration and TPU. That way, it will be faster, correct? Whenever you predict on that machine, it is the same case with the AI fabric also.
So
And
other than speed, is there any need for GPU? Like other than speed, does it affect on accuracy as well?
accuracy, it won't impact. It will only impact on the speed. Accuracy, it will remain the same thing.
Okay.
Yes.
And second, like not related to AI fabric, but why come your UiPath assistant looks the same? It's like since morning I've seen the assistant looks have changed somehow. So I just was curious about that.
Okay, this one.
Yeah, no, not this one. The icon, like on my system, instead of UI, something else is coming, and even the tray, the icon has changed.
Okay, we'll do
So
one thing. We'll
might be
connect
the
after this
beta
session.
version.
We'll connect after this session
Yeah.
and see what went wrong. We can check that.
Okay.
Yep. Thank you so much, Piyush. So, anybody else has any questions? You can post your questions in Q&A also. You can post it in chat also. If you want to speak,
I
you
mean,
can
some
unmute.
of you present as well. So in case you want to speak, you can speak.
And I hope that you guys have loved the entire series. And especially thanks to Piyush and Mukesh for being very rigorous and continuous within each session, and also creating each and every model every day immediately after the session. So that is great. And every one of you have been consistently attending the session. So thank you so much for being there in the session. And I hope you have learned a lot. If you have any questions, post it in chat.
And Piyush and or anyone else is, can you share what was the experience joining today's call? Because this time we are not using Zoom. You found any difficulty or it was easy?
Well, the experience is same as on Zoom, but like when I joined the first time, I thought it was like the screen seemed a little bit blur. I was not able to clearly see what is on the screen, but I was able to manage it by just zooming in the web browser. Other than that, it was like everything was good and cool.
Okay. Anyone else? Uza?
So Santosh is saying he left all the sessions. Thank you so much, Santosh. And thank you for consistently being present over all the sessions.
Yeah, Vipul. So for me also the screen was blurred, and since we don't have that mute option, so a little bit cautious, like which we have for mute and unmute. So that is one thing. My personal opinion is to have the Zoom only. That is much easier to use and everything. So yeah.
Okay, because by default, all the everyone is not able to unmute themselves. So we need to make you presenter if you want to speak.
Mm-hmm. Yeah, so that was like when I joined, I was not aware about it, and I
Yep.
assumed myself as a presenter. So that's why I got confused. Like, and I searched it for a while, like where is the option where I can mute myself, but I did not find. Then later on, I came to know that okay, it's in the host hand. So yeah, maybe it's the first time, so it's a bit difficult.
Yeah. Okay. But all of you are seeing some blurred, or still it's a blurred, or later it improved.